we're going to look at the law of sines. I already forgot. I think it's page 95. Yeah. Okay, thank you. And what this allows us to do is find missing sides and angles of a triangle when they're not right triangles. So up until now, you've only been able to apply trigonometry to right triangles. So that's what you learn in geometry is right triangle trig, and that's the only thing that we've looked at so far. So you can apply it to things that are not right triangles, and that's what we're going to look at here. So for the law of sines, it says previously you learned how to solve right triangle. We will now look at how to solve oblique or non-right triangles. So the law of sines can be used to find sides and angle measures given two angles and a side. So you learned how to prove triangles were congruent in geometry as well. And a couple of your congruence postulates were angle, side, angle, and angle, 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 side, and angle, side, angle. Okay, remember having to do that? So we're not proving them congruent here, but basically you have to have that setup, meaning that any two angles and a side, whether the side is included or the side is not included. Or two side lengths and an angle outside of them, this SSA. Now in geometry, you cannot use this to prove two triangles are congruent. So I always say there's no ass in geometry, you don't get to use that. It's not one of your congruence postulates or theorems. However, it's called the ambiguous case. We're not using it here to prove triangles congruent, but if you have that set up, then it is the ambiguous case and one of two things could happen, and I'll show you what that is once we get there. All right, so let's look at this here. We've got, now I'm going to kind of skip the why behind all of this, but I mean, I could show you how to, I'm just going to give you the lowdown here. This, if I draw in the height here, and then I can get a right triangle out of this, right? So I can find the sine of B, and I can find the sine of A, right? And then I can solve them both for H and set them equal to each other and solve. And when I do all of that, I end up with a little proportional relationship, because whether I use this triangle over here or this triangle over here, I should get the same value for H. Would you agree with that? So if I do it from either triangle, I can set them equal to each other, and that's where this comes from. So I don't want to lose you with all the algebra behind that, because I think you might just tune me out and be like, oh my God, this doesn't make any sense. But it doesn't matter where it comes from. I don't like just giving you things and it's because I said so, but I'm just telling you there is a proof to that. It's not that bad. But the law of sines is very, very simple. It looks like this. The sine of angle A over side length A. Okay, and when you label triangles also, just to make sure we're clear on this, you see how the angles are called A, B, and C? Well, across from those sides, that's a little a, meaning it's a side length, little b across from b, little c across from c, okay? So sine of A over A equals the sine of B over B, which equals the sine of C over C. Okay. And it's that easy. Okay, it's just I'm sorry, what? I'm not lying. I'm not lying at all. It is that simple. Y'all can solve proportions, right? You've been solving proportions forever. Now, can you apply this on every single triangle? No, only if you have this type of information here. That's it, okay? The other ones we have are side, 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 and side, angle, side. That's what the law of cosines. We'll look at those starting tomorrow. So let's look at how we apply this stuff. Let's look at number one. We want to find the missing measure. Again, up until now, we could only use trig if we had right triangle stuff. Now this says round all answers to the nearest tenth. That's because I forgot to change it. So let's just make sure that we're clear on how to answer these questions. If it's whatever, it's to the nearest thousandth unless it says otherwise. It says otherwise, so we'll go with the tenth, because that's what you have to understand is that you got to read it, you got to do what it says, you got to read the directions. Okay, so it says the nearest tenth, that's what we'll do here. If it didn't say, if it just said find each missing measure, then it's to the thousandths. Does that make sense to you? So thousandths unless it says otherwise, we'll go with what the directions say here. All right, so I'm looking for x, right? Well, x is across from 104. And then I have this 47, which is across from 15. So I can set up a proportion. I'm just going to set up that the sine of, we'll start with 47. What will go underneath that? 15. And that's equal to the sine of 104 over x. And then that's all the work you have to show. The rest you can do in your calculator. You're just going to cross multiply 15 times the sine of 104 and divide by the sine of 47. But before we do that, make sure that your calculator always double check on these that little tiny letter up there at the top right there is a D. And I know it's super tiny, but if it's not a D, you're not in degrees. And then somebody could change it on purpose to be mean, or they could change it accidentally by pushing buttons. But even when you clear it, it should stay in degrees. All right, so we're going to do 15 times the sine of 104, and then divide that by the sine of 47. And if you wanted to, because you can with the, fractions on this calculator, you could do it in fraction form. It doesn't matter. But that's what we get right there. Okay? Everybody okay with that? That is my answer. So I get that x is equal to 19.9 centimeters. And let's talk about reasonableness of an answer. Is that a reasonable answer? Yes, we would expect it to be more than 15, right? Because 104 is bigger than 47. So it seems like a reasonable answer. And there we go. Okay. Everybody okay with that? All right. Let's look at number 2. We're not going to do every single one of these, but we're going to do number 2. I'm looking for x. Well, x is across from 42. Right? So that's good. The other side length I have is 28. It's across from this angle. I don't know what that is. Can we find it? Yes. How do we find it? Add them up and subtract from 180, right? Add 42 and 63, subtract from 180, and what do you get for that angle measure? 75. Good job. So now you can set up your proportion, right? I can take the sine of 75 over 28, and that's equal to the sine of 42 over x. Right? So then I can cross multiply and divide. And please tell me if you're not getting the same answers we're getting, because the couple people that have been brave enough to speak up throughout the day in the last week or so, it was something weird that was easy to fix. What was it? One of them was their calculator was in gradients and not degrees. Like, he didn't realize that. And the D, I mean, that's a little tiny thing. And then the other thing was, I don't remember what the other thing was, honestly. I don't even remember. It was just something weird that they were doing every time. All right, so what do we get for this? Okay, so 19.4, if we're going to go to the nearest tenth, like it says. And then that is feet, and we're good. Okay, everybody okay with that? Yes? You got 19.7. Did you type in 15 and 104? And you can arrow over to see what all you type. Oh, you have a plus sign in there. You're making stuff up. Yeah. Nope, no room for creativity. Okay. We good? All right, let's jump down to number 5. 5 says, a pilot begins a flight traveling 80 miles northwest. To avoid a storm, he makes a turn, then he returns to the original location. A diagram of his flight course is shown, so you don't have to draw the picture. Find the total distance of the flight. So if I want the total distance of the flight, that means I have to do what? Find both sides, because I want to find the perimeter, right? So I'm going to name them x and y. So we'll name this one x, this one y. It doesn't really matter. And in the end, my answer is going to be 80 plus x plus y. Like, I'm going to remind myself in the end, I got to actually do something here, right? So let's set this up before we type anything in the calculator. Let's just set them both up. And I'm going to need this other angle here, so let me go ahead and find it. 105 and 15, or was that 108? I'm sorry. I think it's 108, right? I can't read on my board. 108 and 15, so when you subtract, what do you get for this angle? 57, okay. All right, I hear y'all pushing buttons. Don't be pushing buttons yet. Don't get ahead of me yet. So I'm going to use 80, right? And 80 is across from what? 57. I know, it looks like it is across from y, but that side goes with 57. So I'm going to take the sine of 57 over 80 and set that equal to, we'll start with x. So x goes with 15. That's going to be the sine of 15 over x. And then I'm going to set up the other one. Now, I could find x and then use x to find y, but it's safer to use what they gave me. So the sine of 57 over 80 again, that's going to equal the sine of 108 over y. Okay, everybody okay with that? And I want to make sure that we know how to store, because I'm not sure how much we've stored numbers in here, and that's throwing some people off a little bit. So let's find x. We'll find x together here once I find my... Okay. So I'm going to do, for x, I'm going to take 80 times the sine of 15, and then I'm going to divide it by the sine of 57. Do y'all agree with me on that? Because I think I have it backwards on my paper from up there. I want to make sure I do it right. Okay, so I get this number. But I want to store that number, okay? I want to be able to find it again. You are not pushing the alpha key. That's been throwing some people off too. I know in the other calculators you push alpha. We do not do that. So we call this x, we'll store it next. So it's recall, because right above recall it says STO. Y'all see that? And then x is right above the parenthesis. I just hit the parenthesis and it stores it in x. You don't hit alpha and then x. When you tell it to store it, it knows it's pulling the letters, okay? So make sure that that's stored in x. Tell me, you got to speak up if you're not able to store this. And if you're not sure if you stored it, if I hit clear, and then I can just hit recall x. Again, I'm not hitting alpha at all, even though I could. It's not. I mean, it's a different options there. Okay. Okay. Everybody okay with that? And you could also store an A, B, C, D, E, and F up there. So then let's find y. So to find y, I'm going to take 80 times the sine of 108, and I'm going to divide that by the sine of 57, and then store that in y. So I have this number here. I'm going to store this in y. So I hit shift, recall, and then y, which is that key right there. Bam. No alpha or anything else. And it's not a bad idea. So my y was 90 something. I'm going to say, okay, y was 90 something, I don't even know. And then x is 24 point something, right? But I'm not writing them down what they actually are because I'm not typing the decimal back in. Now I realize since we're doing these to the nearest tenth, it may not be that far off, but the farther out you get on the thousandths, it makes a big difference if you don't store your numbers. Okay, everybody got them stored now? So then in your calculator, all you have to do is do 80 plus recall x plus recall y. And you're literally doing 80 plus x plus y. Okay? And storing becomes a very important piece of what we're doing. Thank you. All right. So that is one. So my answer, say total distance is 195.4. Somewhat, yes. And that says total. Okay. Well, now on the back is something completely different, actually. All right. Everybody okay with all that so far? All right. Well, let's look at the back. Okay, so this says watch out. Okay, when finding angles, it's possible to have one solution, two solutions, or no solution. It's possible to have one solution, two solutions, or no solution, because this is called the ambiguous case. With the reason side-side angle did not work in proving triangles congruent was because if we said that, so do you see these two triangles here? We have this triangle. Well, I guess I should call it. I don't know if you can, do you not have this drawn, do you? Okay, so yeah, you can draw it or you can just look up here either way. But A, B, I don't even know if you can read these, but A, B, C, and we'll make this D right here. So you have this triangle that's ACD, and you have this triangle that's ACB, right? So these two triangles have this side length in common, and they share this angle. And then these sides here are congruent. So this is called the ambiguous case because this side length could be here or it could swing out here. Since it's two sides in the angle that are anchored down, since this angle and this side length are not determined, this could swing either way and it could be two different situations, okay? So that's why it's called the ambiguous case. When you go and find an angle, you either have this other angle over here is either this one or it's this one, right? And since this is you see this little isosceles triangle here? See how these two angles here are congruent, right? Tell me about these two angles. What do they have to add to give me? 180. So your two options for the angle that you're going to get when you solve this is either this angle right here or this angle right here. So that means it's the angle you get or 180 minus that angle. Does that make sense to you? There's two different things that could happen. Maybe both of them work. Maybe only one of them works. Maybe neither one of them work because it doesn't even make a triangle. Okay, so when you have the side-side angle, basically when you are looking for an angle, because everything we did on the front, we were looking for sides, right? If you were looking for an angle with the law of sines, you have to check stuff. It doesn't make what you're doing any more difficult. You just have to check it because it doesn't all work. Okay, so let's look at what this says. This says the sine function always has, so sine function always has a range between, so if I asked you for the sine of pi thirds, the sine of pi sixths, the sine of 0, the sine of pi halves, whatever, what's the biggest number you gave me? 1, right? Square root of 3 over 2 and square root, those are all less than 1, okay? So 1 is the biggest one and negative 1 is the smallest one. So the sine of an angle is always between negative 1 and 1. And that has to do with the fact that sine is opposite over hypotenuse. So there's no way that the hypotenuse is going to be any smaller than the numerator. So it's always going to be between negative 1 and 1. So angles with a positive sine function. Okay, so when is sine is positive in what quadrants? First and second, because all students take calculus, right? So first and second quadrant. And to find the other possible angle, like once we come up with an angle, when we solve this, we'll get one number, bam. The other possible angle, you're going to subtract it from 180. Okay. Now, the sum of the angles in a triangle is always what? 180. And no triangle can have two what? What kind of angles can you not have more than one of? Right angles or? Okay, yeah, two right or obtuse angles. Okay. All right. So let's think about this. It says, information about triangle ABC is given below. Check your answer and give possibilities and give all possibilities. Now, does it say anything here what to do with the decimals? No. So that means we go to how many decimal places? Thousands. We go to 3. Okay. So let's draw and label this picture here. And so here's my triangle. Here's A, B, and C. So the measure of angle A is 60, and the length of AB is 30. The length of BC is 27, and I want to find angle C. Okay? So there you go. We have everything that we want to find, and then we're going to set up our little proportion, right? So I'm going to say the sine of C would be over what? 30. And that's equal to the sine of 60 over 27. So I'm going to cross multiply 30 times the sine of 60. So 30 times the sine of 60. And then I'm going to divide by 27. Okay. So I get this, first of all. Now, although we like exact answers a lot, I would also like a decimal at this point. It doesn't really matter. Like, is this my answer anyway? No, this is equal to the sine of theta, or the sine of C, yes? I want C, so what do I have to do with that? I don't divide by sine. How do I do? What do I do? You don't multiply or divide by sine. Okay, it's the inverse, yes. Okay, I've got to take the inverse. So it might make more sense if you look at it as the decimal. It doesn't matter which one you look at it as, but this is the decimal I get. When you cross multiply, this is the sine of C equals this. I don't care about the sine of C. I want angle C. So to do that, I'm not dividing, I'm taking the inverse, right? So I do shift sine for the sine inverse, and then I can just hit answer. Here's my answer, and I'm going to hit equals. Now I'm going to store this in X. Actually, it's C. I'll store it in C. Let's just do that. We're going to do shift, store, and then C is right here above the HYP button. Bam, I've stored it in C. Okay, and I'm also going to write it down because it asks me for this. So the measure of angle C, you still can't do what? Store? Okay. That's not that. Make him feel stupid. That's not nice. Okay.
So once it's 45, and you want to store it, put shift, recall, and you can put it to X. No,
Or C.
X. Or C, whatever. Oh.
Okay.
Now it's there.
Could have been a little nicer about it, but yes, okay. All right. So we get that the measure of angle C is equal to 74.207 degrees, or, okay, so now I want to take 180 and I want to subtract C, right? So I'm just going to do recall C, and I get 105.793. Okay, so 105.793. These are my two options. I'm not guaranteed that they both work. Maybe neither one of them work. Okay, that's what we have to keep in mind. So we have to check them. Here's how you check them. It's super easy. You know that your triangle has to have, or can't have, more than 180 degrees, right? So if you take one of the options, we'll take this 74, or we'll take the angle that's in here, which is 60. We're going to add it to 74.207. We don't even have to be exact about any of this. When you add those two things, is that more or less than 180? Less. It is less than 180, so all is well. It works. If I got more than 180, then I have no room for angle B. Does that make sense to you? So then I take the 60 and I'm going to add it to 105.793. Is that more or less than 180? It's less than 180, so this one works also. So I have two answers here. Okay, does that make sense to you? And that's all you have to do to check it is, okay, they both work. Like you find them both and you got to see if they work. Okay, we okay with that? All right, let's look at number 7. Does that mean what? No, I'm quite sure you have something on your phone that'll do this. Even the built-in calculators do it. Uh-huh. I did 30 times the sine of 60 divided by 27. That gives me the sine of C. So I took the sine inverse of that answer. Okay? Yes? Everybody okay with that? All right, so over here, ABC. C is 89 degrees. AC is 34. AB is 26. And I want to find the measure of angle B. Okay? So I set this up, and I can say I have the sine of 89 over 26 equals the sine of B over 34. So then, everybody with me so far? So in my calculator, I'm going to do 34 times the sine of 89. And then I'm going to divide that by 26. You get 1.307, blah, blah, blah. So remember what we have, what that is, that's the sine of theta. So the sine of theta is equal to 1.3 something, something, something. I don't want the sine of theta, I want theta, right? So what do I have to do with this? Sine inverse. So shift sine, and then my answer, and then equals, what? Math error. Did we do something wrong?
No.
What did we do wrong? Why is it a trick question? Why is there no answer? Yes. Well, sometimes, but sometimes we actually make an error. But look at this. Sine of theta, it can't be bigger than 1, right? So since the sine of theta is greater than 1, you're not going to get an answer. So your answer, really shouldn't have boxed that. Your answer is actually no solution. So we did not mess up. That was the answer you were supposed to get. But sometimes when you get math error, you really did make a math error. So you want to double check that, of course. All right, let's look at number 8. Okay. No solution. We're not doing every single one of these, but we're going to do one, like one of each kind of thing that'll happen. Let's look at number 8. That means it doesn't even make a triangle is what that means. All right, so number 8. Here's my triangle. ABC. And now my triangle is not to scale at all, and I do not care. You make it to where you can label it, and it's absolutely fine. I mean, if you want to make it more accurate, you're welcome to it, but it doesn't really matter. So this is 21, AB is 24, and I'm looking for the measure of angle B. Okay? So I can set this up to give me the sine of 102 over 24 is equal to the sine of B over 21. Okay. So in my calculator, it's going to give me 21 times the sine of 102, and I'm going to divide that by 24. And so just so that we're clear on what we have, that means that the sine of B is equal to about 8 or 0.85, blah, blah, blah. But I don't care about that. I want measure of angle B. So the measure of angle B, I've got to do the sine inverse. So shift, sine, answer. Everybody good with finding the answer part of that? Speak up if we're okay. And I get 58.856. So I'm going to go ahead and store that. What angle was that? B. Okay. So I'm going to do shift, recall, B. It's stored in B. So I get 58.857. So 58.857 degrees. Or I can need to find the other one. How do I find the other one? Subtract it from 180. So 180 minus recall B. And the other one is 121.143. Now, I'm not guaranteed that they both work. Maybe neither one of them work. We'll just have to see what happens here. So I'm going to take this 102 and I add it to 58 point whatever. I don't even have to be exact. And that's less than 180. Right? You agree with that? Then I take the 102 and I add it to the 121 whatever. And that's greater than 180. So this one doesn't work. So I only have one solution, and it is this right here. But as part of your work, you have to show that you found both of them, right? And then that you just chose that one. Okay. Easy enough? We're good? Okay. We're not going to do 9 or 10, but we are going to do 11. Okay, so here's my triangle. A, B, C. Angle B is 125. My picture is really, really not to scale. BC is 24, and AC is 21. I'm looking for angle C. Okay, so I want angle C in the end. Is angle C something I can find directly right now? No, because the 21 goes with the 125, and then the 24 can help me find angle A, right? So although I want angle C, even though I want angle C, I got to find angle A first. Y'all agree with that? Okay, so we're going to start and we'll find angle A and we'll figure out what to do with that. So the sine of A over 24 is equal to the sine of 125 over 21. All right? So in my calculator, I'm going to do 24 times the sine of 125 and divide it by 21. And then that's the sine A, right? So I do sine inverse of my answer, and I get 69.419, right? So you get measure of angle A equals 69.419 degrees. I'm going to store that in A. So shift, recall A. Then how do I find my other one? Subtract from 180. So 180 minus recall A. And I get 110.581. Not yet. 110. Wait, what was the question? Yeah, neither of them. 581. So this is what we get here, right? So then we have to check them. And when you check them and you do 125 plus 69 whatever, well, that's greater than 180. So that doesn't work. And then 125 plus 110 something, Definitely isn't going to work. So you got nothing, right? You got no solution again. What if it would have been less than 180? Okay, so that's a very good question. So let's say that this one had worked. Let's say that this one worked. If this one worked, then I'm going to add these two together, subtract from 180. My answer would actually be that in the end, because I still have to find angle C. Does that make sense? Let's say both of them worked, which is also a possibility. Then you would just have to do both of them in that triangle, and then you'll have two answers for C as well. Okay? Just because, like, up here, whoo, goodness, I hate when I grab the wrong thing there. Up here, if I had, it could be this angle or this angle, which changes the angle up here too. That's why you'd have two answers for both sets of them. Okay, good. Any other questions? That was a good question. Y'all can do this, right? It's a proportion. Just make sure you keep them lined up right. And don't forget with the ambiguous case, you got to check stuff. Okay, we good? Awesome. Yes. Yeah, go ahead. So go ahead and glue or tape this in.